Okie doke. So, you got Earth, you got upper atmosphere. I know this is way off scale, but so very, very thin at the upper atmosphere. I mean, like, it progressively gets thinner and thinner, so like you'll still find gases and stuff way out here, but like it gets really, really thin, but still has a bit of gases and stuff. So here you put a ramjet, but it's not a normal ramjet. This ramjet, it scoops in some very, very light plasmas and stuff like that, so like barely any matter at all, but it scoops up a little bit of it, stores it. Instead of burning it like with fuel and stuff, instead you have a big kite. So up above where the atmosphere ends, you have a big solar kite with a reflector, and then I don't know how to draw sun. So sunlight comes in, bounces off. You'd probably have a collector here that could just, so all this light bounces back to the collector, and then the collector can aim all of it down to the rocket. And the rocket has a radiator where you shine all the light and it just heats up the radiator really hot. And then the radiator heats up all that air that you just squeezed in really tight and shoots it out the back. Okay? So there's that. But then this doesn't shoot all of it out the back. It takes some of it and shoots it out the back, and it takes some of it and it sends it up a tube to the back side of this big sail. So this big sail is a reflector, so it shines the light back. So it does double duty. So on this side, it shines the light into here to give you power to push the surfer along. On the back side, it acts as a big shade, so that back here you just have empty space, and you could make pretty small radiator to radiate infrared heat out, and then you could chill the gases that you collected down to freeze them and bottle them. And then you have a long tether hanging out here, or it could winch up, whichever. And then you could let the bottles fall out on this tether, okay? So a few things about this. So one is, so Earth is spinning. This craft would stay on the sunny side. It would, so if you've got Earth, so sun is coming in from this side. So this side is dark, this is night, this is daytime. So let's see. So the craft would go around this line. It would go north to south. And then it would slightly adjust each as it's going around to stay on this side, because as you go around the sun, you're going to need to adjust your curve because the day and night are going to shift a little bit. Okay, so there's that. Okay, then this is bottom heavy. So this is flying at this is flying slightly slower than its orbital velocity. So if you just took this part on itself without the tether, this would have to actually fly faster than it does. This can actually fly slower not because this is slowing it down, but because this is actually lifting it up. Just like if you take a bucket and you swing it around, the rope is pulling outwards. So normally orbital mechanics, the closer you get to whatever, to the planet or sun or something, so this will go around, this will have a shorter period all the way around, but actually be moving, actually no, it will be moving faster. Anyway, so this one will go this far, say. This one will go this far. This one will go this far. So anyway, so if you put a straight line, if you make this outer circle, this outer perimeter, move at the same radius as this inner one, then you're moving much, much faster than it normally would. So you would end up with an upward force in this direction, okay? But also because you have this upward force, you can end up kind of compromising between this going fast and this going slower. So you can end up going maybe that speed, so like 75%, have this go, say, close to 200%, and meet in the middle somewhere. So this at the bottom would be pretty darn heavy. This would be pretty light compared to it, and this would be very, very light. This would just be a cable, okay? And then this would be some storage, so this could get heavy right here. So this can actually go slower, the heavier and the further out this goes. So we actually want to go slow here, because the faster we go, the more beat up we make this thing. So if we make this thing go too fast, then we melt it out faster. So its lifespan increases the slower we can go. So we can go slower by putting more weight further out on this, okay? And the idea is this: it goes around, scoops up air, and then, so you might think, how are you supposed to pump a vacuum? So like that would take a lot of energy and a lot of machinery and a lot of heat to pump all the way up, say, a kilometer or something like that. But it's not pumping, it's actually dropping. So because this is bottom heavy, it actually just has to release the gas into the tube, and the gas actually wants to fall this direction. Everything is falling up, okay? And so it falls up, gets condensed here, it's actually stopping it from moving, and then the bottles can be released up to the top. And then when they're at the top, they have a lot of momentum to go outwards and forwards. And so with a Dyneema cord, you can get possibly tens of kilometers or even hundreds of kilometers of distance here. And so you could get fuel or propellant from the upper atmosphere to hundreds of kilometers above the atmosphere, and then even beyond to maybe say 50% more or something like that, okay? And then the idea would be that other satellites, I'm terrible at drawing. Other satellites can pick up bottles of frozen nitrogen, oxygen, helium, hydrogen, stuff like that. They can pick up these bottles of frozen gas, store them on their thing, and then just use regular solar panels to melt the frozen stuff. And they can either just squirt it out the back as gas, or they can use onboard ion engines and So a ship, a satellite that might be built to last, say, 1 to 5 years, could be extended to stay up 50 to 200 years. That's on its own, that's not enough. Eventually, you'd have to start integrating things like drones for mobile replacements and repairs. So eventually, the ion engine is going to wear out itself. But you can start building satellites with modular ports and stuff, so that a drone could fly up, intercept it, latch on, and remove the faulty ion drive and bolt on a new one and stuff. And then you could actually have it so that it could constantly be replacing and modifying and stuff. You could also design these to fly themselves to a repair station. So you could have like stations like the space station and stuff. That could have these come in and actually fly into the vicinity. These could catch them with a robotic arm or something. Bring them in to the bay, work on them, do all the repairs and upgrades that they need, and then send them on their way. And then they could actually have recycling in space, so that instead of having to lift heavy material up at, say, what are they at, like $100,000 a pound or something like that? I don't know what the going rate is per pound and stuff. But you can keep all these precious metals and stuff like that up in space, and then just make a junk heap and stuff, whatever. And then once you have enough, then you could start doing refining in space, or factories, or repurposing, or resoldering, or refloating solder, stuff like that. Yeah, but this is basically just this is kind of like a gas station / oil rig for space, but it's solar powered, and it runs, and the fuel is upper atmosphere, so nitrogen, oxygen, CO2, stuff like that. And then ideally, or not necessarily ideally, but probably even so, all the gases that are eventually expelled will end up just falling back into Earth, and we can just use them again and again. I actually don't know. For ion drives, I think it might be fast enough for escape velocity, and it might just keep on going forever and stuff. I actually don't know that part. But we'd be using a lot less and getting it out here and stuff. Yep.